In data analysis, especially for IoT systems, time series data plays a crucial role. Unlike other types of data, time series preserves the order of events. Each entry is linked to a time marker, capturing the dynamics of a process. In IoT applications, time series analysis is essential for three main purposes: forecasting process dynamics, predicting future values with models like ARIMA or SARIMA, anomaly detections, identifying unusual behavior in data streams, understanding system dynamics, gaining insights for monitoring, dashboards, and decision making. Anomalies may appear in different forms: a sudden spike in values, a change response pattern such as an engine taking longer to reach normal performance, shifts in periodic cycles or seasonal patterns, variations in value distributions caused by sensor wear or system malfunction. Let's look at an example: an industrial cooling system maintaining -18 degrees. Normally it cycles through the frost phase, creating small temperature spikes, but a sudden high spike indicates a power supply interruption, an anomaly that must be recognized for reporting and maintenance. To classify these behaviors, we can use a k-nearest neighbors model. Data fragments are compared with known patterns, the frost cycles, normal maintenance, or anomalies. However, differences in fragment lengths and spike positions make direct comparison tricky. This is where dynamic time warping comes in. DTW aligns time series with varying lengths and patterns, allowing more accurate distance measurements. With DTW, KNN can correctly classify system states, even when patterns appear stretched or shifted. For practical implementation, Python's tslearn library offers powerful tools for time series classification, clustering, and anomaly detection. Combined with KNN and DTW, it enables efficient real-world analysis of IoT data. In summary, time series analysis allows IoT systems to forecast processes, detect anomalies, and better understand system dynamics. With methods like ARIMA, anomaly detection, KNN, and DTW, we can transform raw timestamp data into actionable insights.